In the last video, I introduced you to hydrocarbons, and we were looking at molecules that had just hydrogen and carbon, and we looked at molecules that had only single bonds, and we called those alkanes, just single bonds. And we looked at molecules that had double bonds, and we called those alkenes. So have double bonds. And we looked at molecules that had triple bonds, and we called those alkynes. Now technically, the alkenes and the alkynes contain what we call a functional group. In other words, they contain something that is likely to react with another molecule. And a little later in this unit, we'll look at how particularly the molecules with double bonds can sometimes form large chains, because the double bonds can break and then the smaller molecules can link together and form these very large chains called polymers, but we'll get to that later. But right now I just want to point out that the double bonds and the triple bonds are both what we call functional groups. Now, in addition to those, I would like to introduce you to 6 other functional groups. There are, of course, many functional groups that we're not going to talk about, but for today we'll just look at 6 others. So let's begin with carboxylic acids. Now this should sound familiar because we have already done a unit on acids and bases, and as part of that unit we looked at weak acids, and carboxylic acids were weak acids, and these are molecules that contain, I'll just put a dash here, now this dash can be connected to just a hydrogen, or it can be connected to a CH3, or it can be connected to a chain of carbons, it can be connected to whatever. But this part of the molecule is what makes it a carboxylic acid. And this hydrogen right here is the acidic hydrogen, the one that will come off. And these are all weak acids, meaning that most of the molecules will have the hydrogen attached, and only some of the molecules will have the hydrogen off, and the molecules will be constantly losing and gaining the hydrogen back and forth. Remember those reversible reactions we talked about before. So a couple of things to notice about this is that this part of the molecule is going to be polar. We're going to have electrons being pulled toward the oxygen and away from the carbon. So even if the whole rest of the molecule is not polar, like those big long chains of just carbons and hydrogens, those are all not polar. This part of the molecule will be polar. Another thing to notice about it is this geometric shape. We've got a carbon with 3 electron clouds around it, and that will be trigonal planar. All right, let's move on to another thing that's familiar. I guess we'll make them all plural. Amines are weak bases, and we saw these before also. And we started by looking at just ammonia, which is a nitrogen with 3 hydrogens on it. But an amine would be an organic compound that has the nitrogens not bonded only to hydrogen, but bonded to some number of carbons as well. So we'll start with this and just put NH, H. And then we got to remember that that has that unshared pair of electrons, because that's what makes it a base. And this would be bonded to maybe one other carbon with some hydrogens on it, or maybe a whole chain of carbons, or maybe a ring of carbons. It can be bonded to whatever, it doesn't matter. But this is the part of the molecule that makes it an amine. Now, it could also have the nitrogen in the middle. So for example, maybe we'll do this. Maybe we'll have a nitrogen like this, and there'll be some chain of carbons over here, and some chain of carbons over here, and maybe a hydrogen here. And drawing it flat on the board like that does not do it justice, because remember, if we have 3 bonds and 1 unshared pair of electrons, we learned a long time ago, that's going to take a pyramidal shape. So this unshared pair of electrons is going to react with, say, water. So this is all review. We know this from our acid-base unit. It's going to take a hydrogen off that water, so we'll have a reversible reaction where we're going to have the nitrogen now bonded to now bonded to 2 hydrogens plus whatever is off to the side, which may be some chains of carbon molecules. And that's going to leave an OH in solution, which is what makes it a base, because basic solutions have extra hydroxides in them. So that takes care of 2 out of the 6 that I wanted to show you today. Carboxylic acids and amines, which are bases. Now let's look at another one that's a familiar topic anyway, and that of alcohols. So everybody's familiar with the alcohol that you drink, but there's also rubbing alcohol, for example, and all kinds of other alcohols that you're not as familiar with because we don't use them every day. But anytime you have some number of carbons with an OH on it, that's going to be an alcohol. So for example, the simplest one is carbon with 3 hydrogens and an OH like that. And this would be also polar. That's going to be a polar group right there. And this is called methanol. This is the kind, they call it wood alcohol sometimes. This is very toxic. This will make you go blind if you drink it. Whereas if you use this compound, let's just add 1 more carbon to it, that's ethanol, and that's the kind of alcohol produced by yeast when they ferment things to create alcoholic beverages. So this one is in small amounts, not toxic, and this one is terribly toxic. So very different properties depending on the length of the chain of the alcohol. So let's see, that takes care of 3 of them. All right, and then we have something like this, where the oxygen is in the middle of some chain of carbons. So I'll make something simple over here and put just 1 carbon on each side. And that's called an ether. And you've probably heard of ethers. Ethers were the very first compounds that they used actually when they were anesthetizing people for operations, because it knocks people out and it doesn't permanently damage them. It just makes them unconscious so they can do operations. They don't probably use ether anymore, but it was something that they used way back when they were first learning to anesthetize people. And before that, they just, had them bite on a bullet or something, I don't know, but they weren't able to help them. So you can put any number of carbons you want on either side of this oxygen, but it's the oxygen in the middle that is the functional group. And then 2 other things also contain oxygen, and one is, I'll just add 1 carbon for now. Whoops, I wanted to make that. Just a minute. I'm going to put a double bond there, and then remember that we've got hydrogens on these dashes, which I'm going to be lazy and not show you. So this is called a ketone. This particular one is called acetone, so something, again, that's maybe fairly familiar. We've used it a few times in class. And you can make these carbon chains any length you want, but that's still going to be called a ketone. Whereas if I put the oxygen at the end of the chain, that's going to be called an aldehyde. Let's see if I can squeeze that in down here. I can put any number of carbons, again, that I want. We'll put an oxygen there, and we'll put a hydrogen here. Now this probably looks somewhat similar to the carboxylic acid, because if this was an OH, we'd have a carboxylic acid, but making it just a hydrogen makes it an aldehyde. And so again, you can put any number of carbons that you want, or you can actually just put a hydrogen there, but it's this group right here that makes it an aldehyde. So an aldehyde, a ketone is a double bond in the middle of the chain. An ether doesn't have it double bonded, it actually just has the oxygen sitting in the middle of the chain someplace. So those are the functional groups that we will be using this year.